Okay, think about it. How often do you actually use a search engine? Every day, maybe multiple times an hour.
Constantly, right. It's our go-to for pretty much everything.
Exactly. Quick facts, deep research, you name it. But when you get those results back, do you ever stop and think, how good are these, really?
Yeah. Are they accurate? Are they, the best ones for me specifically?
That's the core problem, isn't it? The traditional ways of figuring out search quality, they just don't seem to cut it anymore.
Not at scale. Definitely not. I mean, you used to have people, actual humans, looking at results.
Right, manual review. But that's got to be super slow, costly.
And subjective.
Yeah,
Hugely subjective. It just doesn't work for the, billions of searches happening daily.
no way. And okay, you could do those small online experiments, right? Like A/B testing results on small groups.
You could, and that's more objective, sure. But setting those up, it's complex, needs a ton of technical support, and it's still pretty expensive.
And then there's the whole issue of the content itself. There's just so much stuff online now.
And a lot of it doesn't have that traditional fact-checking layer, so misinformation can spread like wildfire.
Plus, the search results themselves might have biases baked in.
Oh, absolutely. It could be in how pages are indexed in the first place, how they're ranked, or even bias coming from how you phrase your search.
Wow. So it makes it really hard for you, the user, to know what's actually true or trustworthy.
Incredibly difficult.
Yeah.
And beyond just truthfulness, there's relevance. What's relevant changes all the time.
Right. Relevant for me isn't relevant for someone else, and even what I need changes. My simple keywords don't always capture what I'm really after.
So how do search results adapt? How do they get your context, your history?
These are the big, messy problems that engineers and inventors are tackling right now.
At the real cutting edge of search tech.
And that's exactly what we've been digging into for this deep dive. We went through a whole stack of sources, actually. We focused on some pretty technical patents.
Yeah, looking at the blueprints, essentially.
Yeah. To see the latest thinking on these exact challenges. So we're going to explore how they're trying to build systems that can, automatically figure out if results are good.
Without needing humans for every little check.
How they detect and maybe even fix bias and misinformation, both in the results and maybe even in our queries.
And how they personalize things based on our clicks, our context, all that stuff.
The whole goal. Trying to make search faster, more reliable, and hopefully more useful for you.
It's really a look into the future of how we find information.
Okay, let's start with that first big piece. Automating the evaluation of search results. We know manual checks are slow and subjective. What's the automated alternative look like?
Well, the sources describe this fascinating approach using something called partially ordered knowledge base.
Partially ordered knowledge base. Okay, break that down.
So forget just a list of results. Think of it as a knowledge base that understands the relationships between results. It stores the results, yeah, but crucially, it stores this partial order relationship between them.
Partial order. What's that mean here? Like not a full ranking.
Exactly. It means for some pairs of results, the system knows that one is generally preferred over the other based on data. It doesn't need a strict one-to-n ranking of everything against everything else.
Ah, okay. So it knows A is better than B, maybe, and B is better than C, but it might not have a direct comparison between A and C.
Precisely. It captures those relative preferences where they're clear from the data. It's building this map of relative quality.
Okay, a preference map. How do they build this map? Where does the data come from?
It starts with massive amounts of historical user behavior logs. Real interactions, clicks, scrolls, how long people stayed on a page.
Dwell time, things like that.
Exactly. Those logs have all this implicit feedback about what users actually found useful. They mention different strategies for pulling insights from those logs, like time strategy, long click, Skynet, different ways of interpreting the behavior.
Makes sense. User logs are real feedback. But like you said, real data is messy, right? People click the first link sometimes just because it's first.
Oh, absolutely. It's noisy. And that's where this really clever step called denoising comes in. They process this raw behavioral data.
Denoising.
Yeah. Essentially, they build a giant graph showing all the preferences they observed. A is preferred over B, C over D, etc. But the challenge is finding and removing what they call circular structures.
Circular structures. Like what?
Okay, imagine the data suggests users prefer result A over B, and they prefer B over C. But then, maybe somewhere else, the data suggests they prefer C over A.
A is better than B, B is better than C, but C is better than A. That doesn't make sense.
Exactly. It's a loop, an inconsistency, a contradiction in the preference data, likely due to noise.
An impossible preference triangle.
Right, so the system detects these loops in the graph. And then it has to resolve the conflict. It does this by trimming one of the edges, one of the preference links, based on a predefined rule.
Like cutting the weakest link in the chain.
Sort of, yeah. Maybe the link supported by the least amount of data, or the lowest confidence score. This process algorithmically cleans up those internal conflicts derived from, messy user behavior. It makes the preference data much more consistent and reliable.
Wow. So using graph theory to find and fix contradictions in how millions of people clicked, that feels really core.
It's a way to extract a clearer signal from all that noise, turning potentially chaotic behavior into structured preference signals.
Making sense of the wisdom of the crowd, but cleaning it up first.
Pretty much.
Yeah.
And once you have these denoised data sets, maybe from different sources or using different analysis strategies, you need to merge them.
Okay, how do you combine them if they might still disagree sometimes?
That's another interesting bit. They use a kind of dynamic voting system.
Voting for search results.
Yeah. If different data sets have conflicting opinions on the preference between two results, they effectively cast votes. And different data sources might even get different voting weights.
So maybe newer data gets a stronger vote, or data from a known reliable analysis method.
Exactly. It makes the merging process flexible. You can add new data sources later, assign them weights. It's adaptable.
Like a preference election happening constantly behind the scenes.
Kind of, yeah. And there's another challenge. Data sparsity. You just won't have direct comparison data for every single possible pair of results.
Right, the map will have gaps.
So they enhance the data set to fill some of those gaps. One way is using cross-validation. Another is leveraging the transitivity of partial orders.
Transitivity, you mean like if A, B, and B, C, then you can infer AC.
Exactly. If the knowledge base confirms A is preferred over B and B over C, the system can logically deduce that A should be preferred over C, even if it hasn't seen direct evidence for that specific pair. It fills in the map intelligently.
Clever. Automating the logic.
Right. And they can also bring in totally new types of data beyond just basic clicks. Things like analyzing dwell time more deeply using data from similar queries.
How does query similarity work?
Well, they might analyze the words in the queries, or look at whether different queries tend to lead to clicks on the same or similar URLs. They can also correlate URLs, look at composite features, combining clicks and dwell time, and even use position data as a baseline correction.
Okay, so it's a really multi-layered process to build this robust preference map. So once it's built and cleaned up, how do they use this knowledge base to evaluate a set of search results?
Okay, so the search engine generates a list of results for your query, right? The evaluation system then queries this knowledge base. It asks, what do we know about the relative preferences between these specific results in this list?
Got it. It looks up the known relationships for the results shown.
Based on those relationships stored in the knowledge base, it assigns position scores. These scores basically reflect how good it is to have that particular result in that particular position, given the known preferences.
So it knows result X should ideally be higher than result Y based on the map.
Exactly. Then it uses these position scores, often combining them with some preset weights for how important different positions are, and something called interleaving scores.
Interleaving scores, what's that about?
Interleaving is a common technique in search experiments. You take two ranked lists, say, results from the current algorithm and results from a new one you're testing, and you mix them together, showing users a combined list.
To compare them side by side in a real scenario.
Right. Interleaving scores help the evaluation system understand how the results from each list performed in that mixed context, factoring out things like position bias. They ensure the comparison is fair. Sometimes these scores can even be negative, like if one ranking really hurts the visibility of good results from the other list.
Okay, so it's comparing the actual performance in a mixed list against the ideal preferences stored in that knowledge base.
Yes. And the final output is just a single score for the ranking being evaluated. If the score is positive, it suggests the ranking is better than the baseline or the alternative it's being compared against. Negative means worse. 0 means it's basically a tie.
That sounds way more efficient than manual review. It takes the subjectivity out.
That's the idea. The sources really emphasize the benefits. Quick evaluation, much less work for human reviewers, huge efficiency gains, and results that are meant to be far more objective and reliable because they're grounded in large-scale, cleaned-up user data.
The key insight seems to be turning all that messy clicking and scrolling into a clear standard for comparison.
Yeah, moving from opinion to data science for judging quality. That's a big shift.
Okay, so that handles evaluating the ranking. But what about the content? The bias and misinformation problem.
Right, because a perfectly ranked list of garbage is still garbage.
Exactly.
And, like we touched on, bias isn't just about ranking order. It can creep into the index itself, what gets included, or the algorithms, or even start with the user's query. Makes it super hard for you to judge the truthfulness, the veracity.
Especially with misinformation spreading so fast. So how do these systems try to detect and maybe compensate for bias?
One approach involves a component they call a bias monitor. Its job is basically to sniff out potential bias in different parts of the search system.
Like in the index database or the ranking algorithms themselves?
Precisely. Identifying potential problem spots.
Okay, so it spots a potential issue. What then? How does it try to fix it?
Several techniques are mentioned. One is pretty direct,
Yeah.
suggesting modifications to your search query.
Wait, changing my search terms. How?
Well, imagine you use a word like can or may when maybe you need a definite answer. The system might suggest replacing it with does. Or if you use a casual word like help for a medical question, it might suggest treat to guide you towards more authoritative results.
Ah, nudging the query towards more precision or authority.
Exactly. Another example they give is dealing with affirmatively skewed terms. Like if you search, does X cause Y? When the evidence only shows correlation, not causation.
Right, implying a link that might not be proven.
The system might suggest changing cause to something neutral, like and X and Y, to encourage results that explore the relationship more objectively, rather than just confirming a potentially biased premise.
That's really interesting. It's like a pre-search intervention to improve potential results.
Yeah, offering them as suggested alternatives, or maybe rephrased questions. Another angle is tackling the source material, the index itself, if the bias monitor finds issues there.
Like too much low-quality stuff got indexed.
Right. The system can actually modify its crawling strategy.
How it gathers info from the web.
Exactly. Maybe it decides to crawl known external knowledge bases with factual data, like incidence rates for diseases. Or it might crawl known authoritative sources, like major scientific journals or government health sites, more thoroughly going deeper into their links.
Prioritizing reliable sources.
And they can also update the indexing strategy itself. So, scoring content for veracity before it even gets into the main search pool, maybe filtering out stuff that fails basic checks.
Trying to clean the pool before anyone swims in it.
Good analogy. And then there's a really focused effort on scoring the accuracy of individual content pieces directly, especially things like news articles, blog posts, social media content.
Like a truth score for an article?
Kind of. They call it a content score focused on factual accuracy. And they stress the goal is for it to be transparent and explainable.
Okay, that sounds ambitious. What goes into calculating a score like that?
It's pretty comprehensive.
Hmm.
They talk about using algorithmic analysis, looking at a whole range of factors. Things like known measures of journalistic quality,
Okay.
checking if the headline is clickbait by actually comparing it to the article text,
Ah, spotting the mismatch.
assessing the source's credibility, author history, domain type, .gov, .edu. Does it have a clear About Us page? Then analyzing the format. Are there citations, obvious errors, because it's super one-sided, outrageous claims,
Yeah, looking for red flags in the presentation.
and critically, using linguistic analysis, natural language processing, NLP, to detect bias, hyperbole, propaganda techniques, even just gibberish, assessing how arguments are structured.
So it's reading the text for how it's written, not just what it says.
Very much so. It also considers content density, the number of distinct claims made in the piece, and crucially, how many of those claims can be verified, even roughly, by the system.
Verifying claims automatically?
Some, yes. But a really powerful technique here is called stance detection.
Stance detection, what's that?
This is where the system compares the viewpoint or the specific claims in the article against what trusted, authoritative sources say on the same topic.
Like checking it against a known factual baseline.
Exactly. Does the article stance support the consensus from reliable sources? Does it reject it? Or is it neutral or discussing something else? This gives a strong signal about potential bias or factual issues.
That sounds really sophisticated.
It is, and the output score could be presented in different ways. Maybe a probability, like 70% chance this is accurate, or a simple grade, A plus to F, or maybe a little badge or icon next to the link.
With an explanation, ideally.
Yeah, they mentioned the goal is explainability. Why did it get this score? But algorithms aren't perfect, right? Especially with complex or new claims,
True. Nuance is hard for machines.
which is where the human-in-the-loop component comes in.
Bringing people back.
Yes, for the tricky stuff. Some claims can be checked instantly against databases or probabilistically with NLP. But complex claims often need expert human fact-checkers.
So humans handle the edge cases.
And the really important or nuanced claims. The sources describe these experts using specialized tools like AI-assisted workbenches. They build up a reputation, get assigned specific claims to verify, and are given relevant sources and tools to help them assess the content and assign a score.
So it's a collaboration between AI and human experts.
Right. And their judgments contribute to a crowdsourced score, which is combined with the automated score for a final, hopefully more robust truth score.
And the benefit?
Scalability, partly. Once an expert debunks a specific piece of misinformation, that finding can be logged. If the same false claim pops up elsewhere, the system already knows it's debunked. You don't need another expert to check the exact same thing again.
The human effort trains the machine for the future.
Precisely. And machine learning models are trained on all these annotations from experts and the crowd to get better at automatically spotting things like hate speech, extreme political bias, fake news patterns, controversy, clickbait, and so on.
It's a whole ecosystem fighting misinformation.
A multi-pronged approach.
Yeah.
And then finally, how does this all get shown to you, the user?
Right. How does it appear on the results page?
The system can modify how results are displayed. They mention visual indicators, maybe little icons like warning triangles, caution signs, or neutral circles next to links.
Like traffic lights for trustworthiness.
Kind of, yeah. And maybe textual descriptions, too. Things like 82% chance page contains biased content, or page may contain up to 50% biased content, or the flip side, page appears objective authoritative.
Making the assessment visible.
Exactly, making that invisible layer potentially visible before you click. These indicators could even be interactive, letting you click to see why it got that flag. Another idea is appending normative base rates.
Normative base rates.
Like overall statistics relevant to your query. If you search for a medical condition, maybe it shows the general population's chance of having that condition right there with the results.
Providing broader context directly on the page.
Exactly, adding a layer of factual context.
Okay, wow. So automatic evaluation, tackling bias and misinformation. But you also mentioned personalization, making results relevant specifically to me.
Yes, because general relevance often isn't enough, is it? Your needs change, your query might be vague.
Right. How can it know what I need right now?
Well, systems are being developed to use your behavior and your context to personalize the results.
Okay, how does that work? How does it use my stuff?
One method they describe involves re-ranking using contextual signals. So the engine gets a standard set of results first, based on its general index.
The generic list.
Right. Then it receives these contextual signals that contain user-specific features. These can come from different places, different contextual signal providers.
And what kinds of features are we talking about?
It could be your search history, your inferred interest based on past behavior, your current physical location,
Location.
and maybe even interests derived from your social network connections if you've opted into that kind of sharing. Friends' interests, potentially. These features get categorized like query history, document category interest, social signals.
So my past searches, where I am, maybe even who I know online.
Potentially, yes. The system then analyzes how important and relevant the specific features are for your current query and the initial list of results.
Okay, it weighs my personal signals against the generic results.
Exactly. It compares the feature importance to where the results are currently ranked. It might convert scores from different signal sources into a standard format, adjust them based on how trustworthy the signal provider is.
Like, is my location data accurate right now?
Right, or how confident it is about an inferred interest. It might even filter out signals that seem unreliable for this specific query.
Okay.
And based on that whole analysis, how well your personal context matches the documents, it algorithmically determines a new position for those documents.
So it shuffles the list.
It effectively re-ranks the original non-contextual list to create a personalized one, just for you, based on those signals.
Taking the general results and tailoring them using what it knows about me right now.
That's the core idea. Another approach focuses more on learning from your past interactions over time, specifically looking at search sessions.
Search sessions. What defines a session?
It's basically a sequence of queries you make and the interactions you have, like clicking on links, within a certain time frame where you eventually access a result.
So the journey you took to find something useful.
Kind of, yeah. The system learns by associating the results you actually accessed with the queries you used before accessing them within that session.
Okay, linking the successful outcome to the preceding queries.
Exactly. It builds a ranking model that pairs query elements, like keywords or phrases from your queries in that session with the results you clicked on, presumably found useful. It assigns a results score to that pairing.
A score based on past success.
Right. And these scores can be fine-tuned based on what they call positive or negative outcome custom events.
Custom events, like what?
Actions you take after the click that suggest success or failure. So if you click a shopping link and then add the item to your cart, that's a positive outcome.
Makes sense.
If you click a support page link and then immediately go create a help ticket, that might signal a negative outcome. The page didn't solve your problem.
Going beyond just the click to see if it actually worked for you. That's smart.
Trying to get a deeper intent and satisfaction. So the system learns these associations. Then, when you make a new search later,
Yes.
it looks at your new query elements and checks its model for results that were previously accessed and scored highly after similar query elements were used in past sessions.
Finding matches from past successful journeys.
Right. And it can then present these identified, previously useful results alongside fresh results from the main index. But crucially, the ranking of this combined list is influenced by those learned result scores.
So results that worked for me or people like me before get a boost.
That's the idea, making future searches potentially more efficient by leveraging past successes. And there's even mention of customizing based on inferred personal beliefs.
My beliefs.
Yeah.
Whoa, how does a search engine figure that out and why?
It's inferred, presumably, from long-term patterns in your search behavior, the types of sites you visit, the topics you engage with.
Okay, that sounds tricky.
It does. The idea seems to be that the system could potentially determine your likely leanings or beliefs on certain topics, and then maybe generate custom results or modify the ranking to account for your own potential biases related to those beliefs.
How would that work? Give me an example.
Well, the sources suggest maybe selecting a ranking algorithm that prioritizes veracity if your history suggests you value accuracy highly, especially for sensitive queries like health information. Or, perhaps controversially, it might try to compensate if your behavior suggests you tend to seek out information that only confirms your existing beliefs.
So it might try to gently nudge towards more balanced results if it thinks I'm in an echo chamber, or prioritize accuracy if it thinks that's what I want.
That seems to be the direction explored in some of these patents, yes. Tailoring not just to interests, but potentially to inferred cognitive styles or biases.
That definitely raises some big questions about filter bubbles and algorithmic influence.
Absolutely.
Yeah.
It shows just how deep the personalization could potentially go. And finally, all these different versions of results, the original generic list, the contextually re-ranked one, results flagged for accuracy, maybe even the belief customized ones, they don't necessarily have to be shown in isolation. The system could present them in different ways.
Giving me choices.
Maybe. It could be concurrent, like showing two lists side by side, or a split interface. It could be sequential, maybe tabs you can click between, like general results, personalized results, high accuracy results.
Letting me compare.
Or it could be a blended, interleaved format, where results from these different strategies are mixed together intelligently into a single list.
Offering different views or layers on the same search.
Exactly. Giving you more context or control over the lens you use.
Wow. Okay, so just to recap this deep dive, we've seen systems trying to automate search evaluation using that partially ordered knowledge base built from cleaned up user data.
Turning messy clicks into objective quality measures.
Then sophisticated ways to spot and maybe counteract bias and misinformation, looking at the content, the source, the language, even helping refine the query.
Using AI, human experts, stance detection, the works.
And finally, all these methods for personalization using current context, past interaction history, maybe even inferred beliefs to re-rank or customize results just for you.
It's all aimed at making search faster, yet more efficient, hopefully more objective and reliable, and ultimately more relevant to what you actually need in that moment.
When you think about how fundamental search is now,
Yeah.
how integrated it is into how we get information, and then you hear about these systems not just finding stuff, but actively evaluating its accuracy, detecting bias, personalizing based on our history, and maybe even our inferred beliefs, it really makes you think about our relationship with knowledge, doesn't it?
It really does.
I mean, how much of that kind of curation and algorithmic guidance is helpful for navigating the flood of information? And maybe more critically, at what point does it cross a line and start fundamentally changing how we encounter different ideas, different viewpoints, or maybe even challenges to our own thinking?
That's the big question hanging over all this innovation, isn't it? Where's that line? How does this shape our understanding of the world? It's something we'll definitely need to keep grappling with as this tech continues to evolve so rapidly.